So now we're going to look at the area of some two-dimensional shapes. So for now, just shapes with sides. Again, sometimes they're called polygons, non-circular shapes. So when we're looking for the area, it's like we're trying to figure out how much two-dimensional space this fills. Like what I'm shading in right now, what's that two-dimensional space? So area of a rectangle is we get by taking the length times width. So if we look at the formula sheet, it just says LW, but that means L times W. So for this one, we are doing, let's say 94 inches is our length times 8.5 inches for our width. So 94 times 85, or sorry, 8.5 is 799. Now here we're doing inches times inches. So we're getting inches squared, or SQIN, same thing whether we say inches to the second power or SQIN, square inches. So this is how many square inches that would fill in that rectangle. So we have to watch our unit. Whenever it's area, it's going to be square units. So let's say that this is a sheet of 12 gauge steel. The weight per square foot is 5.625 pounds per square foot. Find the weight of the sheet. Okay, so since we have our weight per square foot, first we're going to have to convert this from square inches to square feet. So be careful here. 799 square inches. Square inches to square feet. We're not just using 12 inches in a foot. We have to use 144 square inches to 1 square foot. So we have to be careful of our converting. So 799 divided by 144 is 5.5486. So that's how many square feet that sheet of metal would be. So now we can multiply by 5.625 because this is our pounds per square foot. So really it's like the square feet and the per square feet are going to cancel out. And we're just left with how many pounds that is, which is about 31.21. 31.21 pounds. Okay. And that's not the only way to figure that out. If we kind of looked ahead and we saw that the weight was in square feet, we could have changed 94 inches and 8.5 inches to feet right away. Then we would be using 12 when we're still just in our one dimension. So like right here, we would have divided by 12, divided by 12. But notice doing that twice is like dividing by 144 when they're multiplied together. Okay, so next one is a triangle. So area of a triangle is 1/2 base times height. Okay, and that is because I'm going to draw, if we had a rectangle and we had the base and the height, and then we cut it in half. I'm going to cut this in half diagonally, and we just look at the bottom part, it would be a triangle. So triangles are just rectangles cut in half. This one doesn't look like the same, but you know, if we kind of extend it out this way, extend it out this way, it's like a rectangle, and each part of those would be half, which makes it a triangle. Okay, so 1/2 times base times height. So in this case, the base is 13 inches. So the base always needs to be wherever we're measuring the height, the highest point to a base. So like this is making a 90-degree angle, so that is my height, 7 inches. So notice we don't even use the 9 and the 11, two of the sides, we just use the base, and we need to know the height to be able to do the area. Otherwise we'd have to do some figuring out. So 1/2 times 13 times 7 is 45.5, and again we're doing inches times inches, so square inches here. Okay. So if I didn't know the height, I either have to figure it out, or if we can't figure it out, there's different formulas to figure out areas of triangles that we don't know the height. But we typically, most cases you can figure it out if you don't know the height. So we're just going to be using the 1/2 base times height formula. Okay, so, and that's right here on our formula sheet if you haven't seen that, didn't see that yet. Okay. Next, so this is a, kind of odd shaped sheet of metal, let's say, and we need to find the area. So this one, we need to look at it like two different shapes because there's no formula for whatever shape this is. But if we kind of break it into the top part and the bottom part, the top is a trapezoid. So a trapezoid is when I have two parallel bases. So like the 20 and the 25 are parallel, and then the other sides are not parallel. They could be at different angles. So the formula for area of a trapezoid is base 1 plus base 2 divided by 2 times the height. So it's like what we're doing is we're taking the average of the two bases, so the parallel sides, add them together, divide by 2. So it's kind of like, I'm going to show it on the formula sheet, like if I push this side out a little and then push this one in a little, like what would be the average to make it into a rectangle? So it'd end up being something like that. So the average base and then times the height. So it's kind of like pushing it in to become a rectangle and just doing like our length times width. So, okay, so I'm going to jot it down real quick. Base 1 plus base 2. So that's subscript saying the first and the second. So we don't have to square anything, nothing like that. This is just saying that we're going to take our first base, call that one 20, and our second base 25. And I could have had those different, base 1 and base 2, or I could have had those reversed because I'm just adding the two bases together, dividing by 2, and then we're going to multiply by the 12. Now this time I'm leaving the units out, but when I do the 20 plus 25, that's going to be in millimeters. 12 is in millimeters, so we're going to end up with square millimeters. Now be careful if we're calculating in those parentheses, that 20 plus 25, the whole thing needs to be divided by 2. So what I'm doing in my calculator right now is I'm hitting 20 plus 25, hit enter, and now I'm doing divided by 2. So that was 45 divided by 2. I'll jot this down, 22.5 millimeters. Okay, now I'm going to do times 12, 270 millimeters squared. Okay, now you could do this all in one step in your calculator, but you'd have to put parentheses around the 20 and 25 if you were going to put this all in one step. Okay, so that's for the trapezoid. Now the bottom, this is a parallelogram. Okay, so for this one, area is base times height. Okay, so base being whatever makes a 90-degree angle with the height. So the bottom, top, these are actually the same. So, and then the angled sides are the same on a parallelogram. So the difference between a trapezoid and parallelogram has two sets of parallel sides. So kind of all the angles will be kind of symmetric or reflective. So my base, just like the 20 up top, we're going to assume that it's 20 below. So we're going to take our 20 millimeters as the base times 12 millimeters for the height. So 20 times 12 is 240. And for this one, since we broke it into two, found each of them, now we're going to add them together to get the total area of, that's going to be what, 510 square millimeters. Okay. So when we have an irregular shape where it's not just, I can do one formula, one strategy is to break it up into shapes that I can calculate and then add them together. Now the next one, we could use a different strategy to make it a little easier. So this one, we want to find the area of the shaded part. So we just want the top part. We don't want to include that, that triangle on the bottom. So let's use a different strategy here, where first I'm going to find the area of the whole square. Okay, so this is going to be base length times width, 4 times 4. 4 inches times 4 inches is 16 square inches. Okay, or I think if you look at the formula sheet, we've got for a square, we could have done 4 squared. 4 times 4, 4 squared, either way. We get 16. And now I'm going to take the area of the triangle, 1/2 base times height, remember? So 1/2 times base of 4 inches, height of 1.5 inches. So 0.5 times 4 times 1.5 is 3 square inches. And so since I don't want the triangular part, I'm going to subtract that. 16 minus 3, so the shaded part will be 13 square inches. Okay, so these two strategies we just used, the first one we broke it up into parts that I can do areas for, and I added them together, versus this one I wanted to take out the part I don't want, so we had to subtract. So both strategies are needed sometimes. Okay, so now the next one, I could do either way actually. I could maybe break this up right there, go across horizontally, break it into 2 rectangles, or I can do this full one and then take out that bottom left corner. So either way I should get the same thing. So I'm going to do, we'll stick to the first, how when I draw a line right here, so this bottom one will be 3 1/4 or 3.25 feet times 4.5 feet. So 3.25 times 4.5, that'll be 14.625 square feet squared. Now on the top, I've got 15.5 by, I don't know what that is, but if I do 8 minus 3 1/4, looks like it's 4.75. So this top part is 15.5, 15.5 times 4.75. And that is 73.625. So here I would then add on the 14.625 to get 88.25 feet squared. Okay, which we might as well leave this as a decimal. I mean, it is a quarter, but typically when we're working with areas, we don't really need them in fractions because you can't pull out a tape measure and measure a 2-dimensional area like that. I mean, you can measure the length and the width of it, but there's not really much point changing this back to fractions typically. Usually, you know, and then we go another step, like maybe we need to find the weight of the material or something like the cost of the material, going further like that. Okay. Now I'm going to jump to the next page. I'm going to skip the circle ones for now. That'll be the next video. And look at this one. So this is originally from a sheet of metal that's 16 5/16 by 8 9/16. Determine the original area, and then once the triangular parts have been cut and removed, what's the area? And we're not going to actually need the angles. We're just gonna, we would need it if, you know, we actually had to cut this and lay this out. But let's figure out the area of this. Now, my video time is going to run out to be able to upload. So I'm going to pause it for a minute and then work it out. So if I were you, pause it, see if you can figure it out, and then I'll show the answers in a second. Okay, so final answer should be somewhere around 106.7 square inches. So the original sheet of metal was 139.6758, may have rounded differently. And then each of those triangles should have been 14 for the top one, 8.79 for the bottom left, once we had to find that missing height, and then 10.23 for the bottom right. Again, we had to find the missing height based on the original dimension of the sheet of metal was 8.5625 height. So subtract each of those, 106.7.